All right, so today is the 20th. I wanted to start by talking about section 1.1, called linear equations in one variable. I'd encourage you to take notes in class, but also know if you're online or if you click on the notes, you could always get this online. If I go too fast or for whatever reason, you don't have to worry about being left behind. The notes are available to you. A few things I wanted to talk about to get started are just vocabulary. One thing is the difference between an expression and an equation. Does anyone know what the difference is between them? Yeah. That's exactly right. That's what I was planning with. An expression cannot be solved and an equation can be solved. Also, an equation has an equal sign. An expression doesn't have an equal sign. I also mentioned solve. What those words mean. Solve just means that we isolate a variable, meaning that we get x by itself, we get y by itself, whatever we want is by itself. That's what that word solve means. We could solve an equation. The word simplify means that we combine like terms. We simplify an expression. So we have to get that out of the way first. This symbol that I drew here, that means section. You don't have to draw it, but I will draw it every time we have a section. The way that you do it is you just start making an S, and then you just make another S. That just stands for section. You don't have to do it, but just so you know, that's what that means. Typically, when we're going to do these problems, we follow order of operations. You probably heard the acronym PEMDAS before. P stands for parentheses. E is exponents. M is multiplication. D is division. A is addition. And S is subtraction. When we are simplifying, we go this way. When we simplify an expression. When we solve, we go this way. When we solve equations. So now that that's out of the way, what I wanted to do is get into examples with this. First thing I want to do is just talk about some problems where you simplify. And remember, simplify just means you combine like terms. Like terms just have the same variable and the same variable powers. So just a few examples. If I asked you to simplify 3x squared minus 2x plus 5x minus 6, x to the second. Would be an example. We can't solve it. There's no equal sign. But we look to see what has the same variable and what has the same variable powers. So we have x squared here. We have x squared here. So 3x squared minus 6x squared is negative 3x to the second. This has 1x to the first power. This has x to the first power. Negative 2x plus 5x is 3x. That's what we're referring to when we talk about simplify. Also, we can have a problem where we have to distribute, like if we had 2 times x minus 3 minus x plus 4. Anytime we see parentheses, that means we have to distribute. So we're going to distribute the 2 times x, 2 times negative 3, negative 1 times x, and negative 1 times 4. Once we distribute, we look to see what are like terms. We have x to the first, 2x minus x is 1x, negative 6 minus 4 is negative 10. That is a simplified expression. That's what we're talking about when we say simplify. The majority of this section, we're looking to solve. Solve just means isolate the variable. Isolate just means get it by itself. Well, let's get to some of those questions. First question is 4x plus 8x is equal to negative 9 plus 17x minus 1. This is an equation. There's an equal sign. What we should do first is we should simplify. Let's combine like terms. So I see 4x plus 8x. I'm going to write that as 12x. On the right side, 17x doesn't go with anything on the right side, but negative 9 minus 1 is negative 10. The first step would be that we combine like terms, and that's what we get. Next step, now that everything is simplified, our second step is we want to isolate the variable. We want to try to get that x on one side by itself. So generally when we solve, I try to get the variables on the left side. So in order to get rid of 17x, I want to bring it on the other side. In math, if you want to get rid of something, you do the inverse operation. You do the opposite. If I want to get rid of 17x, I just subtract 17x on both sides. And I get negative 5x is equal to negative 10. X is almost by itself. The negative 5 is in front. We're multiplying negative 5 times x. The opposite of that would be to divide by negative 5. And we get x is equal to 2. That's what we're talking about when we're solving. Generally, we start by adding or subtracting. We go in reverse of PEMDAS. Like if you take a look over here, we added or subtracted, and then we multiplied or divided. The opposite of what we do when we're simplifying expressions. Let's keep going. How about something like this? What if we had 3 times 4 plus x minus x is equal to 5x minus 3? First thing we want to do is simplify each side as much as we can, and then we isolate the variable to one side. So we've seen distribution before. I'm going to go ahead and multiply 3 times 4x and 3 times x. This would be 12 plus 3x minus x is equal to 5x minus 3. Once we did the distribution, we looked to simplify both sides. So on the left side, what terms can we combine? Yeah, the 3x and the x. Okay, so this would just be 12 plus 2x on the left-hand side. There's nothing really to do. So we want to try to get all the variables on one side. I try to get them on the left side. I'm going to subtract the 5x to bring it on the left. So this would be 12 minus 3x is equal to negative 3. We could subtract the 12 to get that on the other side. So we just have 3x by itself is equal to negative 15. Dividing by negative 3 gives us x is equal to 5. You doing okay with this stuff? If anyone has any questions, feel free to stop me at any point, and I'll explain any step if we need to. A couple more left in this kind of theme. What if we had something where it's 6 minus parentheses 4 plus x is equal to 8x minus 2 times 3x plus 5? You can see the problems are getting increasingly more complex. Nothing we haven't really seen before. We see parentheses that tells us to distribute. If you don't have a number outside parentheses, we put a 1 there. So we're distributing negative 1. So we get 6 minus 4 minus x is equal to 8x minus 6x minus 10. This looks a lot like the last problem we did. All we had to do is distribute the parentheses. Let's go ahead and combine like terms. 2 minus x is equal to, this would be 2x minus 10. I would prefer all the variables go to the left side of the equation. Subtract both sides by 2. And divide by the number we're multiplying by to get the x by itself. The hardest kind of problem that you'll see will be this next example. If we had x minus 4 over 4 plus 2x plus 4 over 8 is equal to 5. Most of these problems, what I do is I just add one step to get to the last problem. The one that we just did, we had to distribute a negative 1. That was the only new part. The one before that, we had parentheses. That was the only new part. What's new with this problem is that we have fractions. in one step, we can get rid of fractions. And that step would be to multiply by what's called the least common denominator. Or the LCD. Multiply everything by the least common denominator, that will get rid of fractions, and it'll put us back into an easy equation. Now, if you remember back to when you learned about fractions, what would be the least common denominator between 4 and 8? What's the smallest number that you could divide 4 and 8 into? 2 would be, not quite 2, no. I'm looking to see what number can you divide by 4 and 8. What's the smallest number that you could divide by 4 and 8? If you say 4, can you divide 4 by 4? Yeah. Can you divide 4 by 8? No. I heard somebody say 8. Can you divide 8 by 4? Can you divide 8 by 8? That's the smallest number that you could do that. You could also use 32. You could use 16. The smallest number that you could divide by 4 and 8 is 8. That's the least common denominator. It's almost like if you were going to do what's 1/4 plus 1/8, you would convert 1/4 into 2/8 plus 1/8, right? You guys remember doing that kind of stuff? It's the same idea here, except we have variables. So what you would do at this point is you would multiply everything by 8. Not a big deal. I'll show you how to do that without making it too complicated. What we do is we do 8 times x minus 4 over 4 plus 8 times 2x plus 4 over 8 is equal to 8 times 5. So we're multiplying each grouping by 8. It's really important that you do that. Sometimes people forget to multiply by the 5 by it, but that's what you need to do. What we could do at this point to make things easier is just bring this 4 on the outside. So this is just 8 divided by 4 times x minus 4. This is the same thing as 8 divided by 8 times 2x plus 4. And this is just 8 times 5, which is 40. We're starting to make it simpler and simpler. First step was we figure out the least common denominator, multiply everything by it. 8 divided by 4 is just 2, which we'll distribute in like we did in the last problem. 8 divided by 8 is 1, which we'll distribute in. And now all we have is pretty much the same problem we've been working with for the last 10 minutes. Right? We just had to do one extra step to get rid of the fractions. Let's go ahead and finish this. I'll distribute. X plus 2x is 4x. Negative 8 plus 4 is negative 4. Add 4 to both sides. And divide by 4. We get x is 11. That's the hardest kind of problem you'll see in this section. So if you could figure out what the least common denominator is, you can go ahead and get rid of the fractions. I think it might be helpful, I had a few people volunteered answers that were incorrect before. I think it might be helpful just to practice what a least common denominator is, and then we'll move to the last part of this. So if I just ask you to find the least common denominator, and let's say we had like 1 over 2 plus x minus 3 over 3 is equal to 4. We're not looking to solve it. I just want to know that you understand what least common denominator is. What is the smallest number that you could divide by 2 and 3? 6. That's the least common denominator that you would multiply to finish 6. Also, what if we had 1 over 6 minus 1 over 4? Let me change this. Let's make it 4x plus 1 just to do that. Is equal to 2. What would be the smallest number you could divide by 6 and 4? 12, right? So if you understand what least common denominator means, then you could do those problems that I thought were the hardest in this section. My math lab is good. Have you guys used that before, my math lab? All right, so some people have, if you get stuck with a problem, you could click a button and it'll say solve it for me, and you'll see all the steps to do it. Yeah, so that's great. You also have the smart thinking tutoring. If you get stuck, you could use that. And then starting next week, you'll have me at the tutoring center, or you can make appointments with your tutors. To finish up this section, I wanted to talk about what are called types of equations. There are 3 types. The first type of equation is a normal equation that we've been doing so far. Conditional just means that there's one solution. This is what a typical equation looks like. For example, if you had x plus 2 is equal to 6, x equals 4, that's a normal equation. The answer is 4. You would write the answer is with these brackets, you would just put a 4. Sometimes my math lab wants you to write the answer either x equals 4, or another way you could write that is using those kind of brackets. Another type of equation is what's called an identity. An identity has infinitely many solutions. This is a weird type of equation where you wind up getting the same thing on both sides. So, for example, if you had x plus 1 is equal to x plus 1, what would happen is if you go to solve it and you wind up kind of getting a little confused, if you subtract the 1 on both sides and try to bring the x over, you'll get 0 is equal to 0. That's called an identity, right? The way you would write the answer is you would just say all real numbers. And then the third type would be something called a contradiction. Contradictions don't make sense. This would be an example when you wind up with no solution. No solution would be like if you had x plus 2 is equal to x, and you tried to get all the variables on one side, you get 2 equals 0, which doesn't make any sense. 2 is not equal to 0. So that's an unusual type of equation where we would just say that the solution is a 0 with a line through it. This just means null. Null means no solution. So if you ever see a 0 with a line through it, that means that there is no solution. You can't solve it. to do a couple examples of these unique types of equations, and then we'll move on to the last section for today. But what if I asked you to solve, and I did x plus 1 over 3 plus 2x over 3 is equal to x plus 1 over 3. So the first thing we have to do is figure out what the least common denominator is. This is how we talked about getting rid of fractions. What would the least common denominator for this be? 3. Very good. So what we're going to do is we're going to multiply 3 times each grouping. That'll get rid of our fractions, and then we can just look at the equation in a more basic form. We are, yeah. The directions are to solve this. One thing that I found too is you might be able to do this problem in fewer steps than I do. I found that if I start skipping steps, I make mistakes. So I just show every possible step. When we multiply everything by 3, remember how I told you to do this? We could just bring the denominator on the outside. It's a little bit easier. So it would be 3 over 3 times x plus 1 plus 3 over 3 times 2x equal to 3x plus 3 over 3 times 1. And you're just left with x plus 1 plus 2x is equal to 3x plus 1. No more fractions to confuse us. We can go ahead and combine like terms. X plus 2x is 3x plus 1 is equal to 3x plus 1. If you try to solve this like we do, you wind up with 0 is equal to 0. And this is one of those funny types of equations where it's called an identity. We'll just say the solution is all real numbers. The last problem to finish out this section is if we had 5 times x plus 2 minus 2 times x plus 1 is equal to 3x plus 1. In this problem, we'll finish out with percents and proportions. Like before, we see parentheses, we'll distribute the 5, distribute the negative 2. 5x plus 10 minus 2x minus 2 equal to 3x plus 1. Combining like terms, 3x plus 8 is equal to 3x plus 1. And if we try to solve it, we just get 8 equals 1, which is not true. You can say that there's no solution. Draw that null set like that. That's the